This is practice problem number 2 for section 5.4. It says a particle travels according to the velocity function v of t equal to negative 2t plus 10 meters per second. What is the total distance, this time, traveled by the particle over the time interval from 3 to 8? So total time is kind of like our total area, where we didn't want to take into consideration whether or not the area was above or below the x-axis. We just added the areas together. So the same thing is happening here. We want a total distance, whether that distance is moving to the right or the displacement is to the right or to the left, doesn't matter. We want to add those distances together. So what's going to happen here is we have to figure out where this particle is changing direction. So as opposed to just taking the straight integral from 3 to 8, we have to acknowledge that there might be a spot in there where it changes direction. Well, we can figure out where a particle changes direction by finding where the velocity equals 0. So if we first set the velocity equal to 0, subtracting 10 divided by negative 2, we'll get t equal to 5. So we know that this particle then changes direction at 5, which means that in order to find the total distance, we're going to find the distance from 3 to 5 of v of t. And then we're going to add the distance from 5 to 8 of v of t. Now, I want to make sure that I'm adding positive distances. And just from previous experience, I know that this last one is going to give me a negative distance if I just find the integral. So I'm going to put absolute values around it because I want to make sure to add the positive version of each distance. I don't want to take into consideration the direction that it's going. So plugging this in here, we have the integral from 3 to 5 of negative 2t plus 10 dt. And we're going to add the positive version of the integral from 5 to 8 of this same thing. So taking the integral, I'm going to increase the power, divide by that 2, increase the power. So we're going to evaluate this from 3 to 5, and then we'll do the same thing over here. We have the same integral. And we're going to evaluate from 5 to 8, but again, we're going to make sure that we take the absolute value of our answer. So substituting in 5 here, we get negative 25 plus 50 minus, putting in the 3, we get a negative 9 plus 30. So that's our first one. And then our second one, we're going to have a negative 64 plus 80 minus the negative 25 plus 50. And so that's our second one, but again, we want to make sure we take the absolute value of that. And so here we'll get 4 plus the absolute value of negative 9, which will give us a total distance of 13.